Okay, we're going to graph this sine function. It has a couple different parts to it. Let's start off just by finding the easiest parts. Vertical shift. So let's look right here. Usually this component here, they might move it around on you, but it's right there, -6. Our amplitude, just what you suspected, is 2. Now to find my phase shift in period, I got to do a little work here. Typically it's hidden right where it's inside the quantity. Remember, this could be a theta or an x. But what I'm going to do is factor out that portion right there. If there's a coefficient to your x or theta, get rid of it. So I'm going to take out a 4, makes that x, and I want to say that makes that pi halves. Let's double check. 4x minus 4 pi halves is 2 pi, correct. So I know immediately with my phase shift it's going to be the opposite of right here. So I'm going to make that 5 halves. Pi halves. My period for my sine function is going to be my standard 2 pi. I'm going to divide that by that value right there. Okay? And that gives me pi halves. Okay? So I found all the kind of the needed information that I want to do this graph. So this is all I really have to do. I could always make a chart. It becomes a little bit tedious. I could always do it though. In this particular one, it'd be more confusing than a lot because the period is so small, so it'd be hard to kind of condense everything into what you need. So I'm just going to go by the straightforward, kind of the big 4 components here. So step 1, I'm going to graph out my vertical shift. This is going to be my midline. Okay, there we go. Step 2, I'm going to look for my amplitude. I'm going to go 2 above, 2 below. So above, I'm sure you're neater than me, but you get the idea, 2 below. Okay? So I got that, I got that. What I'm now going to do is I'm going to block in my period, okay? If I block in this, I'm just kind of, this is just me trying to be neat. Now my restriction in this case, I'm just going to go x is greater than or equal to 0, less than or equal to 2 pi. You could do whatever you wanted, but sometimes it's easier just to have a nice few cycles done correctly here. So when I look at my period, I know that my sine wave, which you've already memorized, starts low, ends low. I know that occurs in this amount of place, basically. I know it happens right here, from here to here, and it keeps repeating, right? So I know that it's going to go like this. Boom, boom. Okay, ready? I know that's what happens. Now what makes this one unique is when I phase shift it over, because it's pi halves, everything was replaced. So when I go like this, I'm just splitting this down the middle here. I know here, and I know here. I know that's going to give me a 0. Here we go. And I think you're seeing exactly what's happening here. Let's see what's happening. Ready? Okay. So if you look real quick, 1 hump, 2, 3, 4, and it ends right there. Okay? Now that's incorporating both the phase shift and the period and everything right there. Now just to kind of prove it, why this is a tricky one, let's say you're doing an XY value and you wanted to plug in, oh I don't know, something like pi halves. Okay? Ready? Let's try pi halves. Well, if I took pi halves and I plugged it in here, right here, then I have 4 over 1 times pi halves. Well, this gives me 2 pi. 2 pi, subtract 2 pi is 0. So if I ask myself, what is the sine of 0? Let's just draw it out. The sine of 0 is 0, right? And 0 times 2 is 0, and 0 minus 6 is -6. So at pi halves, I'm at -6. Well, let's see if that worked. At pi halves, I'm at -6. Now what's tricky is when I split that 1 in half, let's try pi fourths. No problem. Let's try pi fourths. Well, if I do pi fourths, I now have 4 over 1, where am I, times pi fourths. Well, that gives me pi. Well, pi minus 2 pi, isn't that -1 pi? Well, if I look right here again and I go to -1 pi, the sign is still 0. Well, 2 times 0 is 0, minus 6, -6, boom. And you're wondering why that keeps happening. Well, it's just a very small increment, okay? So if you jump down to pi 6, we get a messier number maybe, or pi thirds, but you'd see something more relevant. But right now, this is a tricky one because if that's half a pi, right, that'd be half a pi halves would be pi fourths. But half of that would be pi eighths. And that's where you start getting out of the nice stopping points, and it gets a little bit trickier and a few more rules for doing some trig stuff. Okay? So that's your basic function right there. Now remember what that looks like. Boom, 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 stops there. See, all the zeros are nice and neat, and we proved why they worked, correct? So I'm going to show you on a graphing calculator real quick. If I can get the screen to come up. Let's see what happens here. Now, very typically, let's see here. Is this going to show up? Maybe. Is that too much of a shade? We'll see what happens here. Now, very typically, I would always check your calculator. Oops, I was in degree mode. So I'm going to go down, put that in radian mode, get back out of there. I'm going to go to y equals. I'm going to type in my original function right here. 2 sine 4x, I don't know why I'm reading it with you. I know you can read. Second pi, still doing it, subtract 6. Okay, let's double check. Okay, I'm going to hit graph. Okay, now I actually wanted to walk you through the steps a little bit more. So what I'm going to do is this. I'm going to hit zoom 6 just to mess us up on purpose. And I'm going to try to make it look better by walking you through the steps, okay? So to make that picture look like our picture, because we know we're right, is we're going to go into window settings, and I'm going to think about what's really happening. Now my x min definitely was 0, wasn't it? So I'm going to plug in a 0. My x max, I just extended to 2 pi. My original restriction, I said, was going to be greater than or equal to 0, less than or equal to 2 pi. So I'm going to put 2 pi here. I could say 6.28, but I think it's more fun to use the exact values, and I put 2 pi. Now my x scale, since I jump by such small increments, I'm going to do pi fourths, just because it's going to come up a little bit nicer, I think. So I'm going to do pi divided by 4. Okay. My y min, I'm going to do a negative 10. Okay. And my y max, let's just do maybe a 1. Okay. Now that's good. So I'm going to go back to y equals. I'm also going to put in a negative 6, just because I think it will show that midline and make it look a little bit better. Okay, so what I'm hoping you can see, let's see real quick. It's hard doing this neatly here. 1, 2, 3, 4 stops at 2 pi. Let's see if that looks the same. 1, 2, 3, 4 stops at 2 pi. Now we know it went to 2 pi because if you go back again, you look at your window, 6.28 was the max I kind of applied it to. Okay, now I'm just going to use a graphing function, my trace function, and I'm going to go up to pi. Now if I go up to 3.14, I'm right at 0, aren't I? So I'm going to look right there and look over here. Did that give me the same spot? Let's see. It started here at 1 hump, 2 hump, stopped right there at 0. Are we together? 1 hump, 2 hump, stop right there at 0. If you can see that that and that are identical, I think we're doing okay. Okay, and that's about it. Just takes a few minutes. If you can extract what you need and use the vertical, the amplitude, the phase shift, the period, that's going to be the quickest and easiest way to do it. If you ever get hung up, simply make an XY chart and start going. You saw this time it's a little bit tough because, again, the smallness of the increments in between. But there we go. There is your trig function. Good job.